reciprocal trigonometric ratios. We also call them secondary trigonometric ratios, and they each pair up with a primary trigonometric ratio. But the first thing we want to talk about, we want to use this word reciprocal. Well, what is a reciprocal? Reciprocals. Reciprocals are two expressions whose product is 1. Two expressions whose product is 1. If we take an example here, we could say 4 and 1/4 are reciprocals because 4 times 1/4 equals 1. And really what we're doing when we're talking about the word reciprocal is we're flipping the numerator and the denominator to develop a reciprocal. So if we're looking specifically at our trigonometric ratios, a reciprocal trig ratio has, when multiplied with a primary trig ratio, they will have a product of 1. So a reciprocal trig ratio, when multiplied by its corresponding primary trig ratio, when multiplied by its corresponding primary trig ratio, comma, the result is 1. Alright, so let's go ahead and list our secondary trigonometric ratios. We have the cosecant ratio, which is indicated by CSC of theta, and it is the reciprocal of sine ratio. So the cosecant of theta is equal to this 1 over the sine of theta. And we also want to be aware, if we're thinking SOHCAHTOA, sine is opposite over hypotenuse. So cosecant is going to be hypotenuse over opposite. Or, for instance, if we're thinking in our unit circle, where sine is equal to y, then the cosecant is 1 over y. That would be just in a unit circle. I'm going to leave that out for our definitions, though. The secant ratio. Secant ratio is the reciprocal ratio of the cosine ratio, and it is indicated by SEC. So the secant of theta is 1 over the cos of theta, and the cosine of theta is adjacent over hypotenuse, so the secant of theta is the ratio hypotenuse over adjacent. And the last one, the cotangent. Cotangent ratio is indicated by COT of theta. It's the reciprocal of tan, so it's equal to 1 over the tangent of theta. And since tan is opposite over adjacent, the cotangent is adjacent over opposite. Now you might be wondering, okay, how am I going to memorize this? How am I going to remember this? It's pretty straightforward. Cotangent and tangent go together. Cotangent and tangent go together. And each pair has a co in it. So for instance, sine in the primary trig ratios doesn't have a co in front of it, but its corresponding secondary trigonometric ratio does. Its reciprocal trig ratio does. So you have sine and cosecant, then you have cosine, which has a co already, and secant, and then cotangent and tangent go together. Okay, so there's a quick, easy way to remember reciprocal trigonometric ratios. I keep on using the word corresponding. That's accidental. These are not corresponding ratios. There is such thing as a corresponding ratio. This is not that. Okay, these are reciprocal ratios. The relationship is indicated here. If you took the cosecant ratio and multiplied it by a sine of the same angle, you would get 1. Okay, it's the reciprocal ratio. All right, we have a chart to fill in using our primary and secondary trigonometric ratios. We're going to fill in, these are our common angles, special angles, and we have already gone through the unit circle, and we've memorized the sine, cosine, tangent ratio for each of these special angles. And I'm just going to keep the unit circle in front of me to help me think about these things a little bit. But let's look at the sine of theta when theta is 0 degrees. So that's just a flat line here where the terminal and the initial arms are right on top of each other. No angle means no vertical change. So the y distance here from the x-axis is 0. So basically what we're saying is the y coordinate of this point is 0. Okay? Now, what does that tell us about the cosecant of the angle at 0 degrees? Well, 0 is the same as 0 over 1. And so the reciprocal would be 1 over 0. And anything over 0 is undefined. So the first example that we're doing is kind of an awkward example, but anything over 0 is undefined. Make sure that kind of fits in my space so that we don't get too cluttered. Okay? I'm going to stick with these two columns for now, work down them, and then maybe I'll even pause it and let you finish the chart yourself. But we're going to do a 30-degree angle. The sine of 30 degrees, that's the y coordinate at 30 degrees. Okay? That is going to be 1/2, which means the cosecant of theta at 30 degrees, the cosecant of 30 degrees is going to be the reciprocal of 1/2, which is 2. Okay? Look at 45. Cosine and sine are both the same at the 45-degree angle. They are both 1 over radical 2. And so the reciprocal of that is going to be radical 2 over 1, or just radical 2. Just a little note here, something I don't think I've said before. You might also see this given as radical 2 over 2. Okay? These are both the same value. I'm not going to explain it now, but just beware. If you see it like this, some consider this fully reduced, some consider this fully reduced. Some don't like this because it has a radical in the denominator. Okay? So that's fair. Let's carry on. The sine of 60 degrees is actually the same as the cosine of 30 degrees, but the sine of 60 degrees is radical 3 over 2, which means that the cosecant is 2 over radical 3. And the sine of 90 degrees, of course, the angle going straight up in the unit circle is going to have a distance of 1, coordinate of 1, which now if we take the reciprocal of that, 1 over 1 is still 1. Okay? We'll do the same for the cosine here. Cosine at 0 is 1, and I'm going to just bounce off. I know my relationship between sine and cosine, so the cosine of 30 is the same as the sine of 60. So this is radical 3 over 2. At 45, they're the same. The cosine of 60 is the same as sine of 30, and cosine at 90 is 0. So now we take the reciprocal of each. The reciprocal of 1 over 1 is 1 over 1. The reciprocal of radical 3 over 2 is 2 over radical 3. This is for the secant column, so the secant of 45 is going to be radical 2. The secant of 60 is going to be 2. And the secant of 90 is the reciprocal of 0, which is undefined. Okay? Now tangent, if you haven't already memorized it, is a little bit tougher to figure out. But really it's just y over x, or sine over cosine. So again, I can look at what I already have here and go, the tangent of 0 is 0 over 1, that's 0. The tangent of 30 is 1/2 over radical 3 over 2. So the tangent of 30 is 1 over radical 3, reduces to that. The tangent of 45 would be, again, sine over cosine. They're both the same, so the tangent of 45 is 1. Tangent of 60 is going to be simply the reciprocal, reciprocal. I'm going to say reciprocal because when we jump from 30 to 60, sine and cosine switch places. It's just a fraction, numerator over denominator. So this is going to be just radical 3. And the tangent at 90, if it's sine over cosine, and at 90 cosine is 0, then the tangent at 90 is undefined. Okay, now we can do our last column. It's just the reciprocal of the tangent ratio at each. The reciprocal of 0 is undefined. Reciprocal of 1 over radical 3 is radical 3. Reciprocal of 1 is 1. The reciprocal of radical 3 is 1 over radical 3. And the reciprocal of something that is undefined is 0. So you can really see how having the primary trig ratios and the special angles at least memorized. If you don't have them memorized yet, just keep your unit circle nearby. Okay, you should have one maybe printed. Fill it out with all the right answers. There's actually a link to one that looks just like this on Pigeon. That might be helpful to you as we work through these lessons. Alright, well, let's just practice. We have a real triangle here, triangle ABC. It's a right angle triangle, and it's a 3, 4, 5 triangle, and all we're going to do is practice generating these reciprocal ratios. Okay, so we're going to determine all 6 trig ratios, primary and secondary, primary and reciprocal, for angle A, and then all 6 ratios for angle B. So the key to do this is really just staying organized. I'm not going to copy down this triangle so that we're all looking at the same thing. But basically what we're working with for our primary trig ratios is TOA. And so we'll go from there. We're looking at angle A, which is right here. So we can get the sine of A. Sine of A is equal to opposite over hypotenuse, which is 3 over 5. The cosine of A is adjacent over hypotenuse, which is 4 over 5. And the tangent of A is, you could do it 2 ways. You could either do sine over cosine, or you could do opposite over adjacent, 3 over 4. Now to get the reciprocal trig ratios, I left my little chart up here so I could quickly make them. All I'm going to do for the cosecant of A is flip this ratio. Okay? Another way to do it, to think through it, would be, okay, if it's SOHCAHTOA, and I'm taking the reciprocal ratio of sine, then instead of opposite over hypotenuse, I'm looking for hypotenuse over opposite. Okay? Maybe we'll write that in. This is hypotenuse over opposite, 5 over 3. Okay? The secant of A, if the cosine of A is adjacent over hypotenuse, then this is going to be hypotenuse over adjacent, which is going to be 5 over 4. Reciprocal trig ratios can be greater than 1. Okay? And last one is the cotangent of A, which is, instead of opposite over adjacent, it's going to be adjacent over opposite, 4 over 3. Okay? Not much to it. Go ahead and get all 6 trig ratios for angle B by yourself, and then, so pause the video, and then come and check back, see how you did. And there you have your 6 trigonometric ratios for angle B in this 3, 4, 5 triangle. In example 2, we're asked to determine the angle, an unknown angle, when we're given a reciprocal trigonometric ratio. Okay, we're told that each angle is in the first quadrant, so we're only looking for one solution from our calculator in this case, and we don't need to use our tricks to find the second solution between 0 and 360. We just need the first solution in the first quadrant. A here, we're told that the cosecant of angle A is 8. Well, you don't have any buttons on your calculator that say cosecant. You have the inverse cos button, but that is not the same. So what we need to do is we actually need to write another statement using the primary trigonometric ratio that is the reciprocal of the cosecant ratio. Now I've left them up here. It's a good reference for you on your homework page. Just quick draw them out, and there they are if you haven't memorized them yet. But it tells me that cosecant of theta, in this case A, is equal to 1 over the sine of theta. So now I know I can write that. I'll write that this time. I won't write it every time, but cosecant of A is 1 over the sine of A. And all that means is that the sine of A is also 1 over the cosecant of A. And if the cosecant of A is 8, then the sine of A is 1 over 8. Well, now, if I need to find the measure of angle A, all I have to do is take the inverse sine of 1 over 8. Put that in my calculator. Click, 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 click. And I know that's now going to be approximately 7 degrees. Okay, so the angle A is 7 degrees. What did I have to do? I had to take my reciprocal trigonometric ratio, flip it into a primary trigonometric ratio, and go from there. Okay, we're going to shorten this up quite a bit. In B, you don't need to do all these extra steps. That was just to help us think through it. But in B, we're told the secant of B is equal to 5 over 2. Well, I know that the secant ratio is the reciprocal of the cosine ratio. So if I take the reciprocal of my left side, I end up with the cosine of B, which means I take the reciprocal of my right side. The cosine of B is equal to 2 over 5, because they're reciprocal ratios. Which tells me that the measure of angle B is the inverse cosine of 2 over 5, or 0.4. And my calculator will tell me that that is approximately 66 degrees. Okay? Go ahead and try C on your own, and then check back here. Hopefully you're getting that okay. We're just finding the reciprocal ratio, flipping it, putting it in the calculator properly, and out comes your angle measurement. Make sure that your calculator is in degree mode. If it's not, you probably have a button right there that says DRG. That'll change it for you. Otherwise, these guys don't have a reset button, but you could go into the memory, into the settings here, and you could reset your calculator and it will automatically default to degree mode. Example 3 puts together a couple things from this lesson and also last lesson. It asks us to determine 2 angles between 0 and 360 that have a cosecant of negative 2. And then we're going to find out one that has a cosecant of negative 2, and it's going to be in a different quadrant. Okay, so we're going to start off by just indicating that we've got the cosecant of negative 2. I can't do much with that information, so I'm going to take the reciprocal of both sides. Okay, we'll make that little note. Take reciprocal of both sides. Well, the reciprocal of the cosecant ratio is the sine ratio, and the reciprocal of -2 is -1/2. Now, if I'm looking for the angle that has a sine of -1/2, okay, I'm going to draw out my unit circle here to give me a reference. And I'm going to do just that. I'm going to use my reference angle here. I have it memorized that the sine of 30 degrees is 1/2. Okay, so right here, xy, y is 1/2 at an angle of 30 degrees. And I know that the sine ratio is going to be, here it's positive, right? It's positive 1/2. Sine ratio is negative where? Well, C-A-S-T. So sine is positive here, and it's positive here, but it's negative in quadrant 3, and it's negative in quadrant 4. So using my reference angle, I can determine that this guy, if I'm going backwards 30, you don't need to indicate going backwards 30. We don't really do that very often. I'm actually going to wrap all the way around. But just for the sake of explaining, this guy is going to have, I'm not concerned about what its x is, but it's going to have a y of -1/2. And the other place that that's going to happen is way out here, where we've gone another 30 degrees from our horizontal line, from our x-axis, from 180 degrees, and that this coordinate is also going to be x. Not concerned what x is right now. The y coordinate is going to be -1/2. So, summarizing what this is, we used our reference angle in our first quadrant here, which was not the angle that we're looking for, but I know the coordinates of everything in my first quadrant here, so I could tell that y was 1/2 at an angle of 30 degrees. And then using that as a reference angle, I determined that the sine ratio is negative in quadrant 3 and quadrant 4. So using our reference angle, okay, one possible angle, one possible solution is 180 degrees plus 30 degrees, which is 210. The second possible value is 360 degrees minus 30 degrees. That's going back, right? That's our negative angle there, which equals 330 degrees, okay? So we have our first one here at 210, and we've got our next one wrapping all the way around to here. That one's going to be 330 degrees. So two angles between 0 and 360 degrees that have a cosecant of -2 are 210 and 330. We did that by first finding the reciprocal ratio, knowing our reference angles, and then finding the right quadrant. That's it for this lesson. Okay, again, just keeping track of your reciprocal trig ratios, and go ahead and try the practice problems on page 246, numbers 1 through 8.